So the ester that we have been assigned to find is ethyl ethanoate, CH3COOCH2CH3. And we need to find this ester beginning with an alkane or an alkene and storing the roots in order to get from that alkane or alkene into this ester, ethyl ethanoate. So let us begin with the first thing. The first step that we need to go through is how we get from an alkane or an alkene into a halogenoalkane. And the first thing that we're going to look at is from an alkane. So the alkane we're going to be looking at is the alkane of ethane. So what happens first? What happens first is what's known as a free radical substitution. And this is the mechanism. And the first stage is what's known as an initiation reaction. And in this reaction, we are looking to, what happens is two free radicals are formed. And what is a free radical? A free radical is a species that is formed when a molecule undergoes what's known as homolytic fusion. What is homolytic fusion? Homolytic fusion is when two electrons that are covalently bonded split evenly between two atoms, resulting in the two free radicals that are created, as you can see here. And so what's essentially happening is that we see these two covalently bonded chlorine atoms that are split. As you can see here, the electrons are being split, but the condition needed is that they need to be in the presence of what's known as UV light. So in the presence of UV light, these two electrons that are covalently bonded split evenly into two free radicals, as you can see here, the two free radicals. And this is the first stage of initiation, that we gain two free radicals due to this in this initiation reaction. So what's the next step? The next thing that happens is what's known as a propagation reaction. What happens in this propagation reaction is that we start off with ethane. And what happens is that the chlorine free radicals react with ethane, which produces what's known as an ethyl radical. And what happens is the chlorine reacts with the ethane and then forms the ethane free radical. So we can see here the ethane radical is formed plus HCl, and we can see a bit clearer here C2H6, which is ethene, plus Cl free radical becomes a ethyl radical plus HCl. And this is the first stage of the propagation reaction, and this allows for a chain reaction to occur for the second part of the propagation reaction to occur. And the second part is we have the ethyl radical. What happens is the ethyl radical reacts with a chlorine molecule, producing the halogenoalkane that we need. And the halogenoalkane that we have is what's known as chloroethane. And this is the molecule that we produce, right? What happens is our ethyl free radical reacts with a chlorine molecule, creating our chloroethane plus our chlorine free radical. And thus this is how we get our halogenoalkane from the alkane. But however, this is not the end. There's another reaction that occurs, what's known as a termination reaction. And what this is in termination reactions, it reduces the concentration of radicals in the reaction. It slows the rate of reaction, and then eventually it stops it completely. So we can see here that the chlorine, that all the free radicals are coming together, and thus the concentration of the radicals stops or slows down, and then this causes the rate of reaction to slow down and stops. And this is an important part of the reaction, as it is the termination reaction when the free radicals are reduced. And that is the final step of forming from our alkane into our halogenoalkane. However, that was looking from an alkane. We can now look from an alkene, and our alkene that we're going to be using is ethane into a halogenoalkane. Now, next step is from an ethene into our halogenoalkane. So what happens is the alkane reacts via what's known as electrophilic addition reactions. And this is essentially when the pair of electrons or the double bond attacks the hydrogen halide over here. See HCl. This is the hydrogen halide. What happens is that the double bond attacks the hydrogen halide. And what this causes is it causes the hydrogen to attach to one of the carbons that the double bond is attached to, creating what's known as a carbocation. As we can see here, a carbocation is formed. And so we can see that one of the carbons that has a double bond attaches to the hydrogen, causing a carbocation to form, which is a positively charged carbon. And what happens is that due to this, then see here, then the carbocation is attacked by the negative halide formed by the hydrogen halide. So what happens is the Cl attacks the carbocation as it is negative, and thus what happens is it attracts together, so it's a positive and negative, thus creating our halogenoalkane, which is chloroethane. As you can see here, our halogenoalkane is formed, and this is how we create from an ethene into a halogenoalkane. Now, the next step that we have is from our halogenoalkane that we have into an alcohol. So from our chloroethane into our ethanol. So what happens first is we have our chloroethane. So we have our chloroethane here. Now what happens is a reaction occurs due to the dilute sodium hydroxide that we have. And it needs to be a dilute sodium hydroxide, and it needs to be warm dilute sodium hydroxide. So what happens is what's known as an SN2 mechanism. And what that is when one bond is broken and one bond is formed. So what happens is we have our hydroxide ions that are negatively charged attack the positively charged carbon of the halogenoalkane. And what happens is this replaces and substitutes the Cl that we have. So the OH replaces the Cl due to this mechanism. And what happens is we form our alcohol, which is ethanol. So we have here our ethanol. From our halogenoalkane we create an alcohol. So we have our a chloroethane into our ethanol. Now, the next step. Now that we have our alcohol, we can finally create what we needed to make from the very beginning, from an alcohol to an ester. So how do we get from an alcohol to an ester? So the alcohol that we currently have is known as ethanol. So in order to create our ester, we need to, an alcohol can form an ester by heating it with a carboxylic acid. And the carboxylic acid that we're going to be using is ethanoic acid. This is going to be our carboxylic acid. And what we're going to be doing is we're going to be heating the alcohol with the carboxylic acid in the presence of what's known as a catalyst. And a catalyst essentially just increases the rate of reaction. And the catalyst that we're going to be using is H2SO4, concentrated sulfuric acid. So by heating these two in the presence of the catalyst, we get our ester that is formed. So to form our ester, we can finally, from our alcohol, we can finally form our ester by heating it with the concentrated sulfuric acid, H2SO4. So by doing this, we create our ethyl ethanoate as we see here. So from our alcohol, we heat that up with a carboxylic acid in the presence of a catalyst, H2SO4, and thus we finally create the thing that we needed from the very beginning, our ester, which is ethyl ethanoate plus water. And that is how we get from an alkane or an alkene into our ester to create our ethyl ethanoate, CH3COO CH2CH3. So that is the synthetic routes to create this ester. Thank you.